All right, so Chapter 8 is Topics in Analytic Geometry. Today we're going to talk about parabolas. Parabola is a type of a conic section. We're going to do a couple other conic sections. 8.2 I think is ellipses. 8.3 is hyperbolas. I don't know if we're going to talk much about circles, but that's another example of a conic section. When's the last time we talked about conic sections? We did talk about it one time this year. Anybody remember? Oh, did I? Okay. So actually inside the material I talked about it. I also talked about it the first day of school. Do you remember that? Math. Oh, that's when I gave the little lesson. Math bingo. What is a conic section or whatever? So I explained if I take a cone or a couple cones, I'll just look at one cone, and I like chop it like this. You can imagine it looks like that kind of a shape, and that's a parabola. If I chop it straight across, that's going to be a circle, so that's another type of a conic section. If I chop it like, well, actually diagonally like that, that's going to be an ellipse. The parabola's got to be like straight down. So if I go like this and like this, that's a hyperbola, it's called. It's kind of like two parabolas. Actually, it looks like this, like that. I've kind of butchered my cone. That is an ugly cone. Ugly sections of cone. I should have had a 3D model or something. Anyways, if you chop up a cone, you make something called a conic sections, and it's a topic in math. We'll just focus on parabolas today. It's different from what you've done in the past on parabolas. I don't think that you've ever been shown this this type of analysis of parabolas. So what is a parabola? If I take a dot, and I'll call it a focus, and I have a line, I will call it the directrix, and I wanted to find a point that is equidistant from the focus to the directrix. Would you agree that that point right here is the same distance from the focus to the directrix? Pretty close anyways, right? Is that the only point that is equidistant from both of those? No, silly. Because right here, distance from the focus to the directrix. There's another one right here. There's another one right here, another one, and going the other way. These all are equidistant, and they form what is called a parabola. So that's the definition of what a parabola actually is. It's a makeup of all the points equidistant from a point, which is the focus, to a directrix. And this right here is the vertex of the parabola. We talked about vertices a lot when we studied parabolas. Okay, this distance right here from the focus to the directrix is P. And since this is equidistant, this also is P. So the distance from the directrix to the vertex and from the vertex to the focus is always going to be P. The focus is always inside of the parabola. It's inside the parabola. Remember that. Okay, and there's two different versions of equations for parabolas. We could do x minus h squared equals 4p y minus k. And we have y minus k squared equals 4p times x minus h. So notice a couple things. The 4p is always on the non-squared side. So whatever's not being squared, the 4p is on that side of it. This has the x being squared. This one has the y being squared. So if I had like x being squared, like y equals x squared, do you remember, does that open up or down? It opens up. It's just it's the parent equation. It's literally just a parabola. It looks at like that with a vertex at 0, 0. So if I have y equals x squared opens down up, if I have y equals negative x squared, it opens down. It's the same point, it just opens down. So same is kind of true right here. If I have x being squared, then it's either going to go up or down. It's either going to open up or it's going to open down. And the p determines whether it opens up or down. So if p is positive, it opens up. If p is negative, it opens down. So if you have x being squared, it's up or down, and the p determines whether it opens up or down. So for y being squared, if I have a positive p, that would be opening to the right. And if it's a negative p, it'd be opening to the left. This is a positive p and a negative p, opening down. All right, so a lot of this is all going to make sense with examples. And these are all in your notes. So I'm just going to give you some examples, and then you can use it as a resource if you want to. So let's find the vertex. Oh, by the way, the vertex is always h comma k. Vertex is h comma k. So we're going to find the vertex, the focus, directrix, and we always make a sketch. Let's say I have x minus 3 squared equals 12y plus 1. All right, so we're given our equation. It's already in like parabola form. We don't have to manipulate it algebraically at all. So by looking at it, we already know that the vertex is it's 3 comma negative 1. So it's always the opposites of them. Okay, so we've done one of the 4 things we need to do. We already know what the vertex is. So I'm going to make a sketch kind of while I'm doing this. So 3 negative 1, there's my vertex. Okay, this right here is 4p. So we can say 12 equals 4p. So then p equals 3. So whatever is on the outside of the parentheses, that's always equal to 4p. So we set that equal to 4p and solve, we get p equals 3. Okay, so up, very good. I know it's up and down because x is being squared. Because we have x being squared, we know it's up and down. And since p is positive, it's going to go up. So already I'm just going to make a little sketch indicating that that's my parabola, it's opening up. My p is 3. So in order to find the focus, all I have to do is go up 3. There's my focus. This is my focus. There's my vertex. And then to find my directrix, I go down 3. There's my directrix. So my focus is 1, 2, 3, 1, 2, 3, comma 2, and my directrix is y equals negative 4. And that's it. We have our sketch. Dash this line for the directrix. There's my vertex. There's my focus. That's all you need to know, or all you need to know for that problem right there. Let's try another one. So same instructions. All right. give that one a try. All right, what is my vertex? Let's start there. Two, negative 4, very good. So my vertex is 2, negative 4. So I go right 2, down 4. I picked another one in the quadrant down here, quadrant 4. Okay, so there's my vertex. Is this opening up or down? Left or right? It's right, very good, because I have y being squared, so it either opens up or left or right. And since p is positive, that's a positive number there, it's going to open to the right. So already I'm going to do this, just so I don't mess up where my focus and my directrix are. So then you can take that 8 and set it equal to 4p, so p is 2. So go right 2, there's my focus, and left 2, here's my directrix, right on the axis actually. So my focus would be, looks like 4, negative 4, and my directrix, how do I represent that? X equals 0. So it's very, very good. Anytime it's vertical like that, it's always going to be x equals something. In this case, it's x equals 0. Raise your hand if you got something close to that. Nice. So far, so good? Not too bad? All right. Well, you might groan a little bit on this one. So same example, or same instructions. Let's try that. Okay. So it is obviously not in the same form, so we're going to have to do algebra to get it there. I have only y being squared. If x was being squared also, it would not be a parabola. It would be something else. Could be a circle, could be an ellipse, could be hyperbola. Since only one of them is being squared, it's a parabola. So let's move the y squared stuff over to the right side, because if we're going to factor, I want a positive leading coefficient. So first thing I want to do is move that over. It's going to be y squared minus 6y. So, we need to figure out how to complete the square. So what is half of, and the crowd goes wild. What's half of negative 6 squared? So half of negative 6 is negative 3 squared is 9. So I added 9 to the right side. I could subtract 9 to keep it balanced, because right now we just added 9 to one side. We can't just do that. Subtracting 9, but then you have to add it anyway, so I'm just going to add 9 to this side right away. So add 9 there, add 9 to that side. So now I have negative 2x minus 10 equals, well, that factors to be y minus 3 squared. So we're almost there. But we don't know what h is, or maybe not what p is. So we need to factor whatever the coefficient of x is. I have to pull it out. So I'm going to take out a negative 2 and be left with x plus 5. If there's a number there, you got to pull it out. And now I have it in the form that we can use. So go ahead and answer those questions. Vertex, focus, sketch, directrix. The squared's on the right side, but it doesn't matter. The 4p is still over here. All right, so my vertex is negative Up, down, left, or right? Left. Very good. Y squared indicates that it's either left or right, and negative p means it's left. So draw this, then you know where the focus is and the directrix is. So negative 2 equals 4p. P is negative 1/2. Okay, so my directrix is actually like right there. X equals negative 4.5. And my focus would be what? Negative 5.5, comma 3. Are you with me? Okay. Questions so far? All right, so the only other type of question you'll be asked is if you're given some stuff. So, Olivia, give me a vertex. Any vertex you want. 6, comma 3. All right, so we have a vertex of 6, comma 3. And let's say I have a focus of 6, comma 1. I want you to find the equation given that information. So the first thing you want to do is draw a sketch and then see if you can figure stuff out and put it into an equation. I'll give you a minute to try it. Remember, the focus is always inside, so my vertex is 6, 3, my focus is 6, 1, so that's a sketch of it. So it opens down. What's P equal to? No? Negative 2. Right? Because this distance is 2 and it's opening down, so P is negative 2. And once we have the vertex, we almost have the whole equation. Then we just have to find out, well, does it open up or down, and to find P. Oh, okay. So our directrix would be up a couple more, right over here. So y equals 5. We didn't need that for the equation. Okay, so my vertex is 6, comma 3. Already I know it's x minus 6, and I have a y minus 3. Okay, x minus 6 and y minus 3. It opens up and down, so we're going to square the x side. And then the 4p goes on the non-squared side, and you said that p is negative 2, so what would go right here? Negative 8. Very good. So there's our equation. Questions? The only other thing that's in the notes that I forgot to talk about is there's a lot of applications of parabolas and focuses. One would be the flashlight. So the bulb inside of a flashlight goes right on the focus. So the bulb's going to generate light in every direction. But that light goes and it bounces off a parabolic shaped mirror inside the flashlight. And once it bounces off, it's just going to go out parallel every time. So that's how they make the light shoot off in one direction. What's another example where you'd see a parabola in a focus in the middle, maybe? Very good. That's what I had in mind, a satellite. So a satellite's going to generate all this stuff, and it'll do the same thing that like if it generate and all go in like a parallel direction.